Thank you all for the opportunity to present. I'm going to start with the disclaimer. On slide 5 and slide 7 are going to be some videos. They're going to be of a meat processing facility, and to give you an idea, they're going to be like a big butcher store, so they're not going to have faces or names per se. If that's likely to offend you, I won't be offended if you use my first 4 slides to leave the room. 15 years from now, I started thinking about what would the industry look like 15 years from now, and I actually struggled, not because it's difficult, just because I found it so exciting. But then what I started thinking about was, had you asked me 15 years ago to present, what would I have presented on? I would have struggled to find something to present on. So what I'm actually going to present on today is something we started 15 years ago as an industry, and then the second part will be what we're working on today, because I think that's probably what we will see operational and commercial in the next 15 years. So I'm going to talk about automation systems. That's the past stuff, and we'll keep working on that in parallel with new things that we're doing. Objective measurement systems, and then we've been very fortunate to receive a grant from the federal government to actually start to combine these two things together, which is the current stuff that we're working on as an industry. So 15 years ago, the industry had a vision to start automating the deboning process, predominantly in lamb. And I'm pretty happy to say that after effectively 15 years, we've got 3 of these systems in play that are circled there, and a 4th one being installed as I speak. And that doesn't sound like much, but probably market cap is 12 systems. So we're about a quarter of the way onto the journey. So within another 10 years, this will be done and dusted. And this is a system working in a facility on the very far outskirts of Adelaide, 3 hours from the outskirts of Adelaide. And I won't talk too much over this one, but in essence, every one of these animals, or every one of these carcasses I should say, after they're trimmed, go into a room that x-rays every carcass as an individual. So we're getting medical grade x-ray data on everything on every animal or every carcass going through this system. And that's what actually drives these cutters. Every time that machine does one of those swipes, it's worth $2 to the owner of that equipment. So it's about $4 a head benefit for every time those 2 cutters work in tandem. So it's great money to be achieved, and that's just moving $5 or $10 kilo meat into that sweet spot in the middle at $20 a kilo. So millimetres is money. So it's all on x-ray data, every animal individually x-rayed. The next thing that happens is that middle section, which is where the sweet money is, gets further image analysis on it. So we're starting to look at eye meat muscle area, eye meat muscle colour. That's that flash of light that you see. So once again now, every carcass that's processed through this plant, we've got a record at both ends of how big is that eye muscle area. And soon we'll be adding on to it an image system, hyperspectral imaging, actually determine or predict what we think that eating quality is going to be as well. And so the process goes. Now, from a labour utilisation perspective, don't get me wrong, it's one of the most dangerous tasks in that plant because it's normally done with a bandsaw. But we've redeployed 4 unit operations per shift, so that's not a lot. So these things are not about labour saving, they're about getting maximum yield onto the maximum spot. So the next part of that vision, and there's 2 of these systems being installed in Australia as we speak, is to take that first 4-quarter section that was just falling off onto a conveyor belt and start processing that. And at the start of this video, you can see 3 sensors. So once again, we're just getting a whole lot more information on the 3D metrics or 3D dimensions of that 4-quarter. So now we've got X-ray data for every carcass that goes through. We've got information about the eating quality around that middle section. And now we've got some information about that 4-quarter shape and size. Once again, maybe 2 operators for a 10 per minute plant. It's not about labour saving, it's about getting those cuts really, really accurate. So I kept harping on every animal is x-rayed. was a bit of an aha moment for us probably about 5 years ago. And I say us, it's Meat and Livestock Australia, it's the industry, and it's all the solution providers that we use, because I'm not out there actually doing any of this welding or any of this smart stuff. I just hand the money out. Is they worked out that with an X-ray system, single energy, we can find bone. Well, if we actually add a second energy to that, dual energy, we can actually start to find bone and one of the other two characteristics, so meat or fat. And what we've been working on for the last couple of years is to actually say, we can not only X-ray every one of those carcasses for cutting, we can dual energy X-ray it and actually get a really good predictor of CT lean meat yield with an R-squared of about 0.8 to 0.85. So, we loosely call it objective measurement just to differentiate from some of the subjective stuff. This is not truly objective, but it's close enough at the moment to make money on. And so now what we're saying is that we believe all throughout that value chain there's value not being captured. If we could actually start feeding from consumer, back to processor, back to producer, back to genetics about where that meat, fat, bone distribution is and isn't across those three sweet spots or those three different price differentials, we can start to make a difference. So we've got a 4-year program running now, and it's all about, as well as dual energy X-ray, what other systems out there can we build to determine where lean meat yield is across a carcass, and then feed that back to our producers and our genetics guys to start moving where meat, fat, well not bone, but where meat and fat is up and down the carcass. What's really interesting though, if we just measure that, we'll stuff the industry. So what's really important, and I'm not an expert in this space, but enough papers I've read says that if you give the right price signals on the wrong thing, you'll get the wrong behaviour. So if we just give our producers feedback on where we want meat and fat to be, they'll move it, but it will come at the cost of eating quality. So in parallel with this program, we're coming up and further developing more sensors where we can actually give feedback on eating quality and getting that meat-fat distribution correct. The other thing we're starting to work on now as well is actually giving more objective health, animal health information back to the producer. Now that could be seed, so it could actually be contamination, or it could be an organ health issue. Whereas at the moment that's not really, it's done by humans, so it's very, very subjective, often not recorded correctly, being recorded by hand, so it doesn't flow back easily to producers. So we're starting to really get our head around that space as well. Without doubt, there's a bucket load of algorithms. I think in some ways the sensor and the automation stuff in hindsight now is the easy stuff. I think the algorithms and all that data and making sense of that probably becomes the next hard task. And one of the things we're really conscious of is we don't want all these systems out there without a weights and measure type standardisation calibration system across them. I mean, we don't want a producer selling their livestock to 5 processors and getting different standards back or different information back. And we're also starting to look at how we develop systems, whether they be, I'm exaggerating here to make a point, Google glasses that you might wear when you're shopping, or apps on your phone to actually start to get some more subjective and objective feedback from consumers about what cuts of meat are they and aren't they buying. And then ultimately, and this is the bit I definitely don't understand, is giving it back to the genetics guys so they can start to change the traits that consumers are ultimately wanting to pay for. And that's it. Thank you very much.